Day 17 of 60, and today we're killing a habit that's costing you hours. You write a Go handler, then you fire up the server, open Postman or curl, and manually poke at it to see if it works. That loop is slow, it's flaky, and it misses the bugs that matter. The 400 for that should have been a 500, the middleware that quietly swallowed your auth header. By the end of this video, you'll test handlers in process. No server, no ports, no curl. Let's go. Here's the painful way first, so you appreciate the fix. To test a real handler, you'd spin up a server in test main, pick a port, and pray nothing else grabbed it. Port already in use. Flaky test. Server didn't shut down. Leaked routine. You're now maintaining infrastructure just to check that a function returns 200. That friction is exactly why most engineers skip handler tests entirely, and why routing bugs slip straight through to staging. Enter the net/http/test package. The star is test.NewRecorder. A handler in Go is just a function with the signature func http.ResponseWriter or *HTTP request. The recorder is a fake response writer that captures everything the handler writes. So you build a request with test.NewRequest, create a recorder with test.NewRecorder, and call handler serve HTTP req directly. No network. After it returns, rec code is your status, rec body is your bytes, rec header is your headers. 5 lines, fully synchronous, 0 cleanup. Let me make it concrete. Say I have a get handler for users. In the test, req equals test.NewRequest get /users/42 nil rec equals test.NewRecorder, then h.serve HTTP req. Now I assert, if rec code equals http.status OK, t.fatalf with the actual code. That's a passing handler test in under 10 lines, and it runs in microseconds. Run it with go test /, and you get instant feedback on every branch your handler can take. But real handlers talk to a database, and we don't want tests hitting postgres. This is where dependency injection earns its keep. Define a user repository interface with a method like getUser ID string, user, error. Your handler lives on a struct that holds that interface, not a concrete DB client. In production, you pass the real repo. In test, you pass a fake repo whose getUser returns whatever you want. Suddenly, your handler is deterministic. You control exactly what the data layer returns, so you can test every response your handler produces. Now the payoff, table-driven tests. Define a slice of structs, name, the user ID, what the fake repo should return, and the expected status. Then loop with t.run, tc.name, func, so each case is its own subtest with its own name in the output. One row says, repo returns a user, expect 200. Next row, repo returns SQL.error no rows, expect 404. Next, repo returns a random error, expect 500. For the 200 case, you also JSON.newDecoder, recbody, decode, God, and assert the fields. That single table covers your happy path and every error branch, and when one fails, the subtest name tells you exactly which. This catches a classic production bug. Picture a handler that returns 200 with an empty body when the DB hands back SQL.error no rows, because nobody mapped that error to a 404. Integration tests miss it. The request technically succeeds, but a table row that feeds error no rows and asserts 404 fails loudly. You see red, you add the if errors.is, error, SQL.error no rows. Check, return 404, and watch it go green. That's why handler tests beat integration tests for silent data layer mistakes. One last tool, test.NewServer. NewRecorder skips the network, which is perfect for logic, but sometimes you need real TCP, timeouts, redirects, connection reuse, middleware that depends on the transport. NewServer boots a real local server on a random port and hands you a URL to hit with a real client. The rule: NewRecorder for handler logic, NewServer for transport behavior. Day 17 done. Test in process, inject your dependencies, and let table-driven subtests cover every branch. Subscribe for day 18.